Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Yeah, hello everyone. How are you? So, can I have a can you all please write your name in the chat box to confirm your presence so that we can very quickly start? And I see around 7 people are watching the stream right now. And can you please just can you please write in the chat box if I am properly audible and visible? Let me share my screen as well so that we can begin. Okay, so today will be the 11th session of this graph and tree series for interviews. Okay, so I hope everyone can see my slide. Okay, yeah. Thank you, Prerit, for confirmation. Hello, Rohit, how are you? Hello, Prerit, how are you? Hello, Gavini, how are you? And hello, Joel, how are you? So I think we should start, or should we wait for a few more minutes to join the students who are regular in our session? Anyway, yeah, thank you, Prerit. Okay, so let me give you a small introduction about this session and the series, and then we can continue with our topic. So this is today is the 11th session of this graph and tree series, and this series is being broadcasted on GFG Practice Channel. Okay, GFG Practice Channel, and you will find the link of this Jamboard in the description of this video as well. Okay, so in this series started on 5th of December, and we have covered quite a lot of topics related to graphs. Okay, we will start tree after the graph is completed. So the all the theoretical portions of graphs are almost done. Only 2 practice sessions are left. Okay, so today is one practice session, and the next one will also be another practice session. Okay, so in these graph series we have discussed about various things like representation of graphs. Okay, we have discussed about BFS and then DFS. We have discussed other forms of BFS like 01 BFS and multi-source BFS. We discussed about topological sorting. We discussed about connected components. We discussed about how we can find whether a cycle detection in a directed graph, undirected graph, how to do that with BFS and DFS. And meanwhile, while we were discussing these, we also discussed quite a lot of problems which are extremely popular from interview point of view. Yeah, and yes, Mark, I'm great as well. Okay, so these are the topics that we have discussed in these 10 sessions that happened in the month of December. Today is the 11th session, and again today we will be discussing 2 practice problems. Okay, this is a practice session. Okay, so we will be discussing 2 practice problems, and these will be medium to hard category. Okay, these will be medium to hard category, one medium and one hard. Okay, and so let us begin then. I see there are four. People are joining the stream. Okay, and before we begin, let me give you a small introduction about myself. My name is Gourav Kumar Shaw. You can see in this description of the chat box itself for the title of the stream. Okay, so and I am presently in my third year of my BTech at IIT Kharagpur. Okay, so this is about me, and I'm also a mentor at Geeks for Geeks. Okay, so this is a small introduction about me and about this series as well. And the timings of this series are at 10 p.m. daily. Okay, 10 p.m. on YouTube, and the graph series is on every alternate day we planned. Okay, so the next will be on 29th of December. Okay, so next session will be on 29th of December, that is after day after tomorrow. And from the month of January, we will be starting tree. Okay, because after 29th we are having New Year celebrations, so that will be holiday. So from the month of January, we will start with trees, and the tree I will be taking 2 sessions per week. 2 sessions I will be taking per week. Okay, so basically you will have a total of 8 sessions in January, covering the concepts of trees and their practice problems as well. Okay, so this is about tree. So this will be mostly on Wednesday and Friday. Okay, this will be mostly on Wednesday and Friday. 2 sessions every per week. Okay, Wednesday and Friday of every week we will have 3 sessions. So this was about our session, and so let us start with our today's problem. Okay, so let's see how many. Yeah, so we can start then. Yeah, the first problem that we will be discussing today is called Alien Dictionary. Okay, so I hope everyone can see the screen. So let us do the hard problem first, and then we will try to do the medium problem. So this is a hard problem, but in fact it is labeled as hard, but it is kind of a medium problem if you can basically identify the which concept we will use to solve this question. Okay, so yeah, so any ideas, anyone? How can we solve this problem? Any ideas? You can say me. So what I want you all is that you can just write in the chat box any brief idea that you think will be, if you applied on this question, we will be able to solve it. And meanwhile, I am reading the question. So in the question, it is saying that we are given a sorted dictionary of an alien language having n words and k starting alphabets of the standard dictionary. Okay, now we have to find the order of characters in the alien language. And a note is also given. The note says that many orders may be possible for a particular test case. Thus, you may return any valid order and output will be 1 if the order of string is returned by the function is correct, else 0 denoting incorrect string returned. Okay, so it says that you have been given a dictionary, but that dictionary is not something which you already know, the typical English language dictionary. It is an alien dictionary. Why it is an alien dictionary? Because in that dictionary, all the words are consist of only the first k starting alphabets of our English language. So it means that if k is equal to 5, it means that we will take A, B, C, D, and E. So all the words in the alien dictionary are basically formed by only these 5 alphabets A, B, C, D, E. But what happens here is that since it is an alien dictionary, the words will not be in this order. It will not be like that A will come after before B, B will come before C, C will come before D, and D will come before E. This is the normal order. But in alien order, it can be something anything like that. Okay. So the question is asking we have to return that order. I hope everyone is able to understand the question. So this is basically what is the question is asking. So let's see an example. So before I proceed with example, let me make sure that you all understand this concept very well. So it is saying that there is a dictionary. Okay. Now this dictionary is of aliens. Now alien dictionary contains many words. Let's say word number 1, word 2, 3, 4, 5, 6. These all the words are arranged. Now what happens in a normal dictionary? The words are arranged lexicographically. Okay. Let's say this is word 1, this is word 2, this is word 3, this is word 4, and this is word 5. Now these 5 words are arranged according to the rule that A comes before B, A, B, C, D, E, and then X, Y, Z. Okay, so this is a normal order of alphabets, but aliens have a different order of alphabets. The question is saying you are given a value K. K means that the first K alphabets of the English language are used to make this alien dictionary. But it is not necessary that these K letters will follow the same order as the English language dictionary. It may happen that if let's say K is equal to 4, it means A, B, C, and D. This is a normal order. But for alien order, it may be something like this: C, A, D, B. This is the alien order. Okay, so if this is the alien order, so all the words in the dictionary will follow this order. The word will be something like this. If any word is starting from C, it will come before any word that is starting from A or D or B. Okay, I hope you are understanding it. So now we are given an alien dictionary, and all we have to do is find out the order of the word, order of the words, or in fact the order of the alphabets. Okay, so if I have let's say I have been given six words, and from these words I have to make sure I have to tell that this is the real order, this is the alien order of alphabets. Okay, so how exactly are we going to do that? Any ideas? Hello Mark, hello Prerit. Do you have any idea how we will solve this question? Any ideas, anyone? Hello Prerit, hello Gavini, hello Rohit, hello Joel. Okay, so think of an idea that how exactly are we going to make an order? Okay, so let me give you a hint. So let us say I see the first two alphabets of my alien dictionary. I see the first character itself. I see the first character is C in the first word and it is B in the second. So it means that C should come before B in my final answer as well, right? So let us do by the help of an example then. Okay, so let me rub this part and let me. Okay, so yeah. So if you let me share the screen and see. So let's say this is a dictionary word given, which means that this is the first word. B double A is the first word, and A B C D is the second word. So since I see that B double A is before A B C D, it means that B is greater than A. It means that B should come before A in the actual order. Okay. Now if A is coming before, I see A B C D, and the third letter is A B C A. So the first two characters are the same. So we cannot judge anything. In fact, the first three characters are the same, but I see D and A are different. So it means that D should come before A. Okay, so B should also come before A and D should also come before A. Okay, so according to the first three letters, I can make out that B should come before A as well as D should come before A. So it makes sense that B, D should come before A. Okay, then I see that A should come before C and B should come before A. Okay, and this is one character, and then I see that B should come before D. Okay, so final order will be that consider the first four characters of the English language. So A, B, C, D, we are considered characters under consideration. But now A, B, C, D is the order of normal order. The alien order is B, D, A, C. So this is the order aliens have used to construct the dictionary. And the dictionary, if following this order, will be something like this. Now the question is that we have to output this character B, D, A, C in the form of a string. Okay, I hope everyone understood it. Okay, so any ideas how we will do it? Okay, let's see how we will do it. So, I can give you a hint about this problem. So, this problem will involve the concept of. So, this problem will involve the concept of topological sorting. Okay, so this will involve the concept of topological sorting. Now, I have already discussed about topological sorting in my previous videos, so previous sessions. So the concept topological sorting, how we will use. So we know that if there are any, let's say node U of a graph and a node V of a graph, and if it is connected by a directed edge, we will say that in our topological sorting, U should come before V. Okay, because U is connected to V. This is the first observation. Second observation is that topological sorting is always applied on directed acyclic graph. It means that our graph should be directed, it should be acyclic. Okay, so if there are any cycles, then the condition of topological sort will become null and void. So we cannot apply topological sorting. So now how to apply this topological sorting in the question of alien dictionary? Okay, so how we will do that? So since I've already told you that we will apply topological sorting, is there anyone who can write me a small brief description of exactly how should we apply topological sorting to solve this problem? Anyone? We have quite a good number of audience right now with me. So if anyone who thinks, just write briefly. Prerit, did you understand this question? Hello, Joel, did you understand this question? And the same for Rohit and Gavni as well. So if you are there, can you kindly write in the chat box that you have understood the question and you're thinking? Think for a few minutes, then I will go to the solution part. Anyone? Can anyone answer me the question about? So let me share the questions tab as well. So if anyone is trying to read the question, can read this, and I've already given a hint that we will be using topological sort to solve this question. Okay, so if anyone of you knows how can we just apply the concept of topological sort to solve this question, you can just answer me. Okay, so yeah, this is a very good question. See, as you can see, this is a hard level question, and understanding that we will be applying topological sort to this question is actually a very uh, it's kind of difficult to just know the idea that we can apply. Okay. Hmm. Hello, Nikaj, how are you? Okay, then let me discuss the approach. Okay, so the first thing that as I told how to do that is that let's say I have got two strings. Okay, for example, let's say I have got two strings. This is string s1 and this is string s2. I compare the first character of the string s2 and I find that the first characters are different. So let's say the first character here is equal to c and here it is equal to d. So since in our alien dictionary the c is coming before d, it means that in the actual order of our alphabet, c should come before d. Okay, now the idea that some alphabet is coming before another alphabet can be migrated from the concept of topological sorting. So what we can do, we can consider C and D to be the nodes of a graph. For example, I will consider C to be one node and D to be another node. And whenever I see that C is present before D, I will just put a directed edge from C to D. Okay. Now let's say I consider the next two strings. I see A here. Then I see D is before A. It means that D is coming before A. So what will I do? I will make a connected edge to A. Okay. So let's say this is our graph. Okay. So what will I do after that? So I have been given n strings, let's say, and I will first of all check each and every string, every pair of string. Okay, starting from number one, I will check the string at first two position, then the string at the number two and number three positions. Okay, in that order, I will keep on checking, and I will keep on making the directed graphs as well. After I am over with this iteration, I have a directed graph. Now now in the question it is given that it is always possible to construct the order. Means the question in the alien dictionary that we are receiving in the question is a valid dictionary. It is not a wrong dictionary. So if it is a valid dictionary, we will always see that this graph is directed acyclic graph. Okay, it will not form any cycle. This is we are considering. In the question it is said that it will be a valid dictionary. Okay. So after we construct this graph, all we have to do is find the topo sort of this graph, topological sort of this graph. When we are finding the topological sort of this graph, we will automatically get an order CDA, which will basically represent the correct order of alphabets the aliens have chosen. Okay, or the on the basis of which the alien dictionary is constructed. Okay, I hope everyone got the idea. Hello, Nikas, did you understand? Okay, so this is the idea we are trying to do. Okay, now let us see how we'll try to write a code here. Okay, so I have already shared the screen here. Okay. Now the first and the most important step here is that we have to basically iterate over this dictionary thing, and then we will check for every two numbers. We will basically take the for every two number at I and I plus one. We will see which of them is forming an order. So the code for that purpose would be something like this. Okay. So we have to basically create a graph in the form of an adjacency list from the dictionary we are given. Okay. And how to do that? The first step would be to declare an adjacency list, okay, of size k. Why k? Because we are taking the first alphabet. In the question, it is mentioned that we have to consider the first k alphabets of our English language. So if k equal to 5, we will consider A, B, C, D, E. So now this A, B, C, D, E can be in any order, okay, to form the alien dictionary. So now we are taking the first two strings. We will iterate from I equal to 0 to n minus 1. because we are taking at any given iteration we are taking the present string and the next string. So we take the two strings, then we take the minimum of the length. Why minimum of the length? It will be because we are trying to basically take a pointer and try to go across every digit. Now, if the digits are not equal, if the characters are not equal, it means that that character is coming before the another character. If the, let's say, the first unequal character is C and D, so it means C should come before D. So I should create an edge between C directed to D. Okay, this is the idea. So this for loop is basically doing that only. So if they are not equal, okay, so what will happen? It will create a adjacent, it will create a directed graph. Okay, so let me just type out this stuff and tell me. Okay, so let's say if the first character is A, B, C, D, and in the second string is A, B, C, A. Okay, so this is the two characters of a given string. Okay, I see that the first three characters are exactly same. A, B, C is same and A, B, C is same. But when the fourth character D is greater than A, okay, but in actual what happens, A should come before D in normal alphabet, but in alien's alphabet I see D is coming before A. So this condition will become true, that str1 of ptr is not equal to this. And then what will I do? I will just I will just make a the connection from D to A. So how will I denote D? I will just denote whatever character it is minus A. Okay, so this is zero based indexing. So if the character is A minus A will be 0. So I'm denoting the character number A as 0, character number B as 1. So this is how we are denoting nodes, because I am forming a node adjacency list of integers. Okay, so that is why I am converting the characters to its valid integer values. Okay, I hope everyone understood this, how we are able to convert our given dictionary in the form of a in the form of a adjacency list. Okay, so this part is done. Now let us see something like this. The next part would be to do a topo sorting. The next part would be required to do a topo sort. Now, what exactly is a topo sort basically? Topo sort will return me the actual topological sorting. So let's say I create a function here, which is returning me a string. Okay, so let's say it is returning me something as a string. Okay, or in fact, an array maybe. Okay, so topo sort is returning me an array, because topo sort will help me get the array. Okay, now I am creating a function topo sort. Okay, so this is a topo sort. Now what will I do? I will call this topo sort function. Okay, so this is how I will call the topo sort function. I will declare a vector. I will call the topo sort function. I will send the k value. K will be the number of vertices v. Okay, capital V, and this will be an adjacency list. Okay, so topo sort, and this will be an adjacency list. Okay, so this will be equal to vector int adj. This is an adjacency list. So now we have to implement our topo sort algorithm in this function, which is standard code to topo sort. So this topo sort function will return the actual topological sorting of our given directed acyclic graph. Now what is left? Now we already have the topo sort. Now all we have to do is print in the form of an answer. Okay, so what we will do basically, we will declare a variable called answer, and we will iterate over topo sort, and we will just add our answer to it, whatever the value is present. We will just append a to the value so that we can get the character, because in our topo sort array we have integers value stored, and we want to convert it into characters. So that is why we will be doing answer equal to answer plus character it plus a. Okay, and then we will finally return our answer. Okay, so I hope everyone got this concept. Okay, and we will return answer. Now all we have to do is apply the concept of topo sort. Now topo sort is a we have done it previously, the concept of topo sort. So let me just paste the code of topo sort. So this is the concept of topo sort we have already done by using BFS. This is the Khan's algorithm implementation. Okay, so initially what we do, we first of all declare a vector of in degree, in which we basically store the in degrees of all the nodes. Okay, we do an in degree plus plus. After that, we declare a queue, and inside that queue, we first of all push all those nodes which has an n degree equal to 0. After that, we declare a topo vector, and after that, we run a while loop. Now, when we are running the while loop, we take the front element of our queue, we push it into the topo sort vector. Yeah, after that what we do, we basically run a for loop, and then we visit every adjacent node. Now whenever we are visiting an adjacent node, we decrease its integrity by 1, and as soon as the integrity becomes 0, we again push it into our queue. So this is how the idea of topo sort will work. Okay, so let me just submit this problem and check whether it is correct or not. Okay, so there was just a variable naming issue. So as you can see, after I corrected, it got successfully accepted. Okay, so as you can see, the all the test cases have passed. Therefore, this concept is correct. So, is there any doubts in this question? I'm pasting the link of the question in your chat box. You can try this question out. This is a very good question. The implementation of topo sort. Okay, and this question is very frequently asked in interviews. Okay, so this question is done now. Do you have any doubts in the question, or should we proceed to the next question? Okay. Okay, then let us move to the next question then. So our next question is something like this. It is called minimum multiplication. Okay, so let me share the screen. So will be our next question. Okay, so let's see how to do this. So the let me read the question statement, problem statement first. And the problem statement is saying that we are given two numbers. The first is a start and an end, and an array of n integers. At each step, what we are going to do, we are going to multiply the value of start with any of the number in the given array. Okay, and do a mod with 10 to the power 5 as well. So when we are multiplying with 10 to the power 5, we get a new value. Okay. Now the thing is that we have to find the minimum number of multiplications we can do to the value start so that we can reach the value end. Okay. For example, let's say this is our array 2, 5 and 7, and we have to reach 30 from 3. So what we do, we multiply 3 with 2 and get 6. And then we multiply 6 with 5 and get 30. So we reach 30. And the number of multiplications we needed was 2. So we will output 2. Okay. Similarly, when we want to reach 66175, what we are doing? We are multiplying 7 with 3 and getting 21. 21 when multiplied with again 3, we get 21 into 3 is equal to 63. And again, when we are multiplying 63 with 65, we get 4095. When we are multiplying 4095 with 65, we get 266175. But the question is asking us to always take a mod of 10 to the power 5. So because since this value is exceeding 10 to the power 5, its mod will be 66,175. So we have already reached the answer end. So we required 4 multiplications. So our output would be 4. Okay, so this is the idea of and we have been asked to implement an algorithm in an expected time complexity of 10 to the power 5. Okay, and space complexity, we will also be taking a space complexity as well. Okay, 10 to the power 5. So how exactly are we going to solve this question? Any idea? Okay, so I can just give you a very small hint. The question is related to graphs only. Okay, since we are doing a series of graph, it is very obvious that this question will be graph. Now, the best part about this question is that you have to basically connect the idea of how we are going to apply the concept of graph to solve this question. Okay, so any ideas, anyone? Like if you have any ideas related to how it should be, so you can just type it in the chat box. Okay. Yeah. So so I can give you another hint that let me just share my screen here. Okay. So let me write something like this. Okay. What exactly we are doing here? Hmm. So let me write an example here. So let's say the start is 3 and end is 30 and 2, 5, 7 is our array. So 2, 5 and 7 is our array, and start is equal to 3 and end is equal to 30. So let's say I have the number 3 here. Now I can pick 3 elements from our given array. The first will be to multiply it with 2, the next would be to multiply it with 5, and the next would be to multiply it with 7. So when we are multiplying with 2, we are able to see 6. And then we are multiplying with 5, we see it is equal to 15. And then this will be equal to 21. Okay, now again, since we are at 6, we again have 3 options to multiply. So basically what we have to do, we multiply 6 with 2, we get 12. We multiply 6 with 5, we get 30. We multiply 6 with 7, we get 42. Similarly for 15 as well, 3 multiplication, 21 as well, 3 multiplication. Now the concept here is that we have to reach 30. So whenever we are reaching 30, we basically see that this is our target. So we saw we reached 2 steps to take here. Now it may happen that as long as we're able to reach the target, we will return 2, which is our answer, because we need 2 multiplication to get this. Okay, Naika is asking recursion. Not exactly recursion. Basically, since the thing here is that we have 10 to the power 5 values, okay, and this will become a kind of a tough. So as I already gave you a hint, so we have to apply the concept of graphs here, and we have to find the minimum number of multiplication necessary. Okay, so what I can say here is that I want you all to imagine these numbers 3, 6, 15, 21, 12, 30, 42. Every means every number which we can basically get if we are multiplying the as the start and keep on multiplying as a nodes of a graph. Okay, so let's say I'm saying that your starting node is node number 3 and your ending node is node number 30. And I'm asking you that how many, like what is the shortest path you can reach from node number 3 to node number 30? Okay, so you can go from node 3 to node 6 and from 6 to 30, because this is a viable path. Because when you multiply, there exists a path from node 3 to 6, because if you multiply 3 with 2 you get 6, and if you multiply 6 with 5 you get 30. So there are two edges, so I can say the cost is 2, so I will return true 2. So which algorithm comes in your mind basically? Okay, so if someone is asking, if I just hint I gave you, so which algorithm comes to your mind? Anyone? So Naikach, can you please write in the chat box a brief description about the idea that we can apply to solve this question? BFS, will BFS work? Because BFS, basically the idea seems similar to BFS, but BFS also has limitations. Okay. Now, what does BFS do? It goes across every of its level. It will traverse 6, 15, and 20 when it will traverse to its next level. But the thing here is that I want to find the shortest path here. Okay. So BFS doesn't help. BFS will not actually yeah, BFS. The thing is there BFS, but basically we want to find the shortest path here. Okay. So which one will apply? Any idea? So basically, yes, the concept of BFS should work here. Yeah, actually, BFS will be working here, but yeah, because the concept of BFS is something like this that will apply one. So, but I don't want you to stay directly BFS because this idea is sometimes similar to another famous known algorithm. So I want you to mention that algorithm. Okay, but hmm, because that particular algorithm and BFS both are similar kind of, and it will help us to reach our solution. For BFS, priority queue will be needed. Are you sure we will be using priority queue in this question? Like what we are trying to prioritize here? Is there anything we are trying to prioritize? Fluid version? No, not fluid version. See, why we will need a priority queue? We are not prioritizing anything. So, in Dijkstra's algorithm, we were using priority queue because we wanted to find the shortest path where every edge is a different weight. But do you see, all the edge has same weight. Every edge here has one weight, because if I'm traveling from 3 to 6, the cost is 1, and from 6 to 30, the cost is 2. So total cost is 2, because every edge represents one multiplication, and I have to return the minimum number of multiplication. So I need to find the shortest path. So which algorithm gives us the shortest path, single source shortest path? Which is that algorithm? Like, how can I know an algorithm which will help us find the shortest path from start to end? So just let me just tell you. So it is basically the Dijkstra's algorithm. Okay. So we will be applying the Dijkstra's algorithm here to find the shortest path from the start to as long we are able to find the our target. Okay, but what happens in Dijkstra's algorithm? We were using priority queue, because in normal Dijkstra's, what happened that we have weight associated with each of the edges. Now each of the edges can have different weight. Okay, and we have to find that path. When we sum up all the weight, the answer is minimum. But in this question, since all the weight are basically same, so Dijkstra is also kind of a BFS type of algorithm. In BFS, we use queue, and in Dijkstra, we are using priority queue and updating the distance array. But in this case, what we will do, instead of using priority queue, we will just use queue, because it makes no sense to use priority queue or a mini hybrid type. So we'll just use queue, because when we are starting at 3, 3 will insert its adjacent elements 6, 15, and 20 in the queue. So 6, 15, and 20 are at the same level, level 1. Now 6 will, now when we are processing 6, 15, and 21, we will insert the next part of its level. So as you can see, this entire concept is approaching level wise level. So basically, inside of my priority queue, initially all those nodes will be there, which is at a distance of 1 unit. Then again, all those nodes will be there, which is a distance of 2 units, then 3 units. So basically, the number of multiplication is 1, 2, 3. But the idea is that we are proceeding like this. But the idea is that as soon as we reach our target, we will stop. Okay, that is the idea here. So initially, we will proceed, see 1 multiplication, 2 multiplication, 3 multiplications. Then I see that at 2 multiplication, I am able to reach 30. So I will just say, okay, yeah, I'm done here. So this is the idea of how we are applying a little bit modified version of Dijkstra's algorithm to find this. Okay, so when I will be showing you the code, this will become much clear. Okay, so you can see the code here, right? So let me explain every code line once. So the first and the most important thing here is that we have a start variable. So we're declaring an array called answer. In this answer, I have the size of the array is 10 to the power 5 plus 1, because there are 10 to the power 5 numbers are there, and each possible number is a possible value of a node. Okay. Now initially what we are doing, we are marking it as unvisited. So we are marking everything as -1. After that, what we are doing here is that we are pushing the value of start into our queue. Why start? Because that is our starting point. And one more thing, the question is asks us to take mod at every point. So whenever we are pushing anything into our queue, we will take a mod, because we don't want it to exceed 10 to the power 5. So we push our start. Now after that, this answer array is this is the equivalent of distance array. So we already had a distance array in our Dijkstra's algorithm, the array which we were trying to update at every iteration. So we will write this is equivalent of the distance array. Distance array of Dijkstra's algorithm. Okay, so equivalent of the Dijkstra's algorithm. Okay, so what we will do, since the Dijkstra's algorithm, what we used to do, we used to mark the distance of the source as equal to 0, because the distance required to move from source to the source is equal to 0. So that is the reason we are marking the answer of start as equal to 0. I hope everyone got it. Hello, Nikos, are you able to get the concept? And yeah. Okay, so now what we will do, we will run a while loop. Okay, now why we are running the while loop? We are running the while loop because this is a standard Dijkstra code. We take the top element from our front of the queue, the populate element. Now we see whether that element is our answer or not. Just like we should check whether that element is our target node or not. If that was equal to target node, we will just return this value. Okay, because why we are returning this value just immediately and not updating it is the reason here is that what it was happening is that we are pushing all the nodes into the queue which are at a distance of one cost, and then the two cost. When all the one costs are over, then we are pushing the two cost. So we're progressing something like this: one, two, three. So we're progressing in ascending order. So whenever we are able to reach the end, it means that that is the minimum amount of multiplications we need. Okay. So how are we performing the multiplication? We traverse across our array, and what we do, we declare a variable called pushed, and that is equal to top into the value of ARR of I, and then we take the mod. Okay, now we see that whether it is equal to minus 1 or not. If it is equal to minus 1, it means that it is not yet visited. So what we will do, we will push it into our array. So answer of push is equal to whatever answer the top contains plus 1, because it is at a new step. Okay, so we are trying to update the number of multiplications in our array. Okay, because let's say in our question we reached from 3 into 2 was 6. So 6 is at a distance of 2 unit, at a distance of 1 unit. Okay, so answer of top, the first was 2, so it was 0. 0 plus 1 equal to 1. So we are now pushing q dot push equal to the value of pushed. And in our answer, we just updated that we can reach the value 6 after one multiplication. It means now as soon as we get the value, our answer variable, that is the target, we just return whatever it is stored in answer at that point of time. And if after in this entire operation of the while loop, if you are not able to get if you are unable to get this statement, it means that we are unable to reach our target by anyhow. Okay, our algorithm could not reach the value of target. So in that case, we will just return minus 1. Okay, I hope you all understood the concept. So let me just submit this problem and check whether it is correct or not. Yeah, so this question is correct. So the time complexity of this question will be something like this. Since we are not visiting all the nodes, there are 10 to the power 5 nodes, and it is not possible that our array is such that we are able to generate all the 10 to the power 5 nodes. Okay, so basically in that case, what is happening here, the upper limit of time complexity remains as 10 to the power 5. Okay, it means so that we can basically apply the digextual algorithm. Okay, so this is the thing. So I hope everyone understood the concept of how we are doing it. Okay, so do you have any questions related to the two questions we discussed? Any doubts related to the two questions we discussed? So we have discussed two very important questions: the medium question and the hard question. And the first was involved with topological sorting, and the second was involved with digextral. Okay, so in the next session also I will be discussing two more problems. It will again be of hard to medium level category, which are very frequently asked in interviews. Okay, so yeah, and let me tell you that our next session would be our very last session for graph series. From January onwards, so we'll be starting with our series for trees. Okay, so this will involve all the concepts related to trees. So you can rewatch the previous sessions and get an idea about the topics of graphs. And our next session would be the last session for graph. Okay, and after that, the tree session, I have already told this in the previous part of the, well, we're starting this session, is that from January, basically every week we will have two sessions for trees, and those two sessions we will be discussing concepts related to trees, and a total of 8 sessions will be there, and in fact everything will be covered in trees related to that. Okay, so important point from interview. So it will mostly be on Wednesday and Fridays. Okay, so I hope that you all stay with me till the very end of January so we can cover up the session. And one more important thing, I want you all to kindly like this session in the YouTube stream, as well as subscribe to the Geeks for Geeks practice channel, because we at Geeks for Geeks have basically thought of delivering a great content to you all. So right now, Graph and Tree series are going on. Again, in the we will be starting with a DP series as well. So another mentor of ours will be starting for a DP series. So if you are regularly watching the contents of our channel, this will prove very beneficial for your upcoming internships and placements preparations. Okay, so I hope you guys will follow our channel. And yeah, in case if you have any questions, you can ask me. I am here for a few more minutes. Okay, then see you day after tomorrow. That is on 29th of December, and I would request everyone to kindly subscribe to the channel as I just said, and yeah, enjoy your holidays as well. So see you on 29th of December, and after that we will be seeing you on January first week. Okay. Yeah, thank you, Naikaj. Thank you, Raghu, for your appreciation. So, if I follow this playlist, will I be able to crack any graph problem? Basically, in the playlist, we have limited amount of time, and so we are delivering limited amount of content. But in actual, the content are huge. So, apart from following the playlist, you have to basically solve the other questions as well, which are relevant. Okay, so it's not like this playlist is very comprehensive. We are having a total of around, let's say, today was the 11th session. So we are having 12 sessions. So 12 session is approximately 12 hours. So it's not possible to deliver 100% of content in 12 hours, but we have delivered all the topics, the important topics, the concepts, and the frequently asked problems. Now it's your idea to basically practice more and more problem. Okay, yeah, in that case, you can just yeah, so Raghu, what you can do here is that in that case, you can practice a lot of questions following the easy and the medium, and then you go to hard. GFG practice portal has extremely good questions as well. You can follow other platforms. Lead code is there, that is also good, and interview bit is also there, which is very good for interview point of view. Okay, so this was from my side. I hope everyone enjoyed today's session. So see you on 29th. A very good night to everyone. Bye bye.